So today we are going to discuss an interesting topic, what they don't tell you about. So this is a topic related to PostgreSQL on Kubernetes. And myself, Jobin Augustine, I am PostgreSQL tech lead for Percona. And this topic is interesting because when someone venture into the Kubernetes area, especially when they try to run PostgreSQL on Kubernetes, they will learn things on the way. So there will be a lot of things which are not documented and things which are not aware previously. They start learning a lot of things. So this is more of a presentation about how I learned things which were not clear to me before I start using PostgreSQL on Kubernetes. And this can avoid many of your struggles, the early struggles. So the first thing, so there is a disclaimer. The views and opinion expressed in this presentation are of the author, myself, and do not necessarily reflect the official policy and position of Percona. So this is about my learning, and the content provided of the author's opinion and not intended to hurt anyone. So I could have my own bias, definitely, because after all I'm a human. Yeah. So and I'm not claiming to be a Kubernetes expert. I am a PostgreSQL person. I learned Kubernetes slowly over the years, that only for PostgreSQL purpose. So with that, let me give a small introduction about myself. I am with databases for quite long, with last 25 years or more. I'm working on databases including Postgres, and I'm a hardcore PostgreSQL enthusiast and frequent presenter in many of the conferences, and publisher. I publish a lot of blogs and articles. And nowadays, lesser number of participation in many of the conferences because I have difficulty in traveling. But in the future, I'll improve on that side. And I love performance tuning, optimization, troubleshooting, all those stuff. And currently, I maintain a project called pggather, which is currently part of Percona distribution. But it's free and open. It's an independent project. It's my own project. The idea is all the learning which I had over the years, all my nodes are converted into automated scripts. So the troubleshooting should become easy. This is a diagnostic tool. Anytime if you have a problem with your Postgres database, just try it out. So instead of going through a lot of DBA scripts and figuring out what could be wrong, just try this out. Majority of the problems will be easy to troubleshoot. There are cases where it took less than 1 minute to figure out what went wrong. Yeah, please check it out. And about today's talk, why this talk and today's agenda. And the main point is there are a lot of narratives about how to run Postgres on Kubernetes, and that comes with the developer idea about so the developers will have some idea how to run Postgres on Kubernetes, and many of those narratives will turn into expectation of the end user. So the end user will have an expectation based on the narratives. So if the narratives are slightly off, that will affect the expectations. And if the expectations are not met, that is going to be a dissatisfaction. So people will be cribbing about something or other later. And there is something which I need to be touching upon in more details, the memory management in containers and Kubernetes in more in depth, because that is the area where many people are blind about. And bit of availability and performance aspect of running Postgres on Kubernetes, and the day two operational gap, how to manage the databases after the deployment. So with this limited time available, these are the areas which I want to cover. The overall target is to how to prevent breaking the expectation, how to set the expectation correct, and so that there won't be pain later. Yeah. And the narrative. So I didn't mention one thing. When it comes to running Postgres on Kubernetes, many people tried running directly on Kubernetes with their own way. That will be really painful. So I strongly recommend to have an operator. So the company for which I am working, Percona, has a Percona operator. It's one of the best operators for the Kubernetes. Please try it out. And my recommendation is avoid running your own way directly on Kubernetes, because some of the Postgres conferences I heard a lot of negative comments of someone trying to run Postgres directly on Kubernetes in their own way, because it's going to be really complex. So the first narrative which I want to address is, with operator, we don't need DBAs. There is some narratives happening in that side. So we need to check the reality about that. The DBAs are not just doing the provisioning. Provisioning is one of their activities. So the major work of DBAs involves the schema design and maintenance. End of the day, the design determines the quality. So if the design is bad, it doesn't matter what all effort we put to tune it, nothing will be working out. If you want to design a sports car, you need to design it that way. So you cannot take some random car and make it a sports car. So the design of any system, the user environment, the application, all those things are the places where the expert DBA need to be involved in the first phase. The design is super important. And the table design, the data selection, data type selection, the indexes, constraints, some of the heavy queries, whether we can use metallized views, all those decision making is what DBA need to do. And the operator is not going to do that. So the confusion about operator and the DBA's work is coming because operator is termed as a automated operator, and DBAs are termed as human operator. So the automation of operator, the Kubernetes operator, is not going to replace the human operator. Human operator is responsible for a lot of things, which we need to be very clear. Without this clarity, many people, many organizations, I would say, they removed DBAs from the seat, and finally they got into the trouble, because everything which I am going to discuss will be affected if there is no responsible and knowledgeable person in the seat. So, and another part of the DBA work is to manage the expectation of business and application. So there are certain things which won't work. So we need to be clarifying that to the application and business. What should be expected out of available hardware, available resources, and what is your plan about that? And concurrency optimization. Say every user may want to have their query to be running on the system the fastest possible way, but the databases is a shared resource. It is not individual SQL running or of one person running fast. It is the overall system delivering the business value. So sometimes we may have to sacrifice certain things, and for the better concurrency, some of the sessions we may have to slow down. Say for example, Postgres supports parallelism, SQL parallelism. Same SQL statement will be running on multiple cores at a time, parallelly. Some of the scans will be happening in parallel. And all those things gives performance advantage for that SQL, but at the same time there could be some other SQL getting affected because of that extreme parallelism, because there is limited resource available on the server. So all those things need to be discussed. And coming to the tuning, there are different levels of tuning, the host level tuning, database level tuning, session level tuning, and at the end the SQL level tuning. So the automation, the operator is not going to do any SQL tuning. So that is something which need to be handled by a human, the DBA, the real human operator. And indexing decision, whether to have an index, remove all the indexes. We publish multiple blog posts about the disadvantages of indexes and what type of indexes required, upgrades and migrations. So all these things involves a lot of human effort. The decision making, partitioning decisions, and how to execute that. There were cases where somebody implemented partition, again because of the pressure from business they had to go back. So the handling all those situations, backup policies, strategies, all those things need to be managed, maintaining maintenance plans, negotiating downtime windows, and most importantly, stopping the user from doing wrong things. That is what the biggest value a DBA need to do. So many people will be asking to do certain things which is not appropriate for the overall health of the system. So the DBA should be able to say no. That is those strong decisions are something which human operator need to do. So majority of these things still requires a human to be there in the seat. So that expectation need to be managed. And reality is the DBA job is just like parenting. The day-to operations are important, and that requires people to be there. We don't have a robot to handle all those things yet, but we don't know in future that may happen. But until now, we need people to handle all those things. So and one of the narrative is because the DBA don't need because the people want to project it in a different way. But the reality is the operator environment will be like a DBAS environment, database as service environment. But if you consider existing DBAS environments, they acknowledge the importance of DBAs. So here is some of the documentation reference from AWS. They are the number one in DBAS operation, no doubt. And so what DBAs need to do, what are the DBAs responsibility, all these things are documented. So they expect DBAs to be there in the seat. The DBAS is not a replacement for DBAs. And the operator automation is how to get this database as a service running. That's it, not DBAs. And another narrative which I want to address is the micro databases. When we talk about Kubernetes, it is all about microservices. That's how the thing started. And there are people propagating this narrative that databases also can be micro databases, handling only limited set of data, very small databases scattered along. But that is very difficult. Practically, that is very difficult because data is always connected and related. Say my age, 48, that number is having a value only if that is associated with myself. So if that stand independently, that's just a number. So data is always connected, related. That's why we are talking about all relational databases. It cannot be detached. So every data is dependent on the primary key. And detaching data is difficult, and many people try to do the distributed databases, but the reality is cross database queries are very tough. Ensuring the integrity is very difficult. Distributed queries are problematic, and Sometimes in many cases it may not be possible, and we know how difficult it is to implement some of the sharding techniques like a Citus, because even today what we see is they have a provision to club all the schemas, co-host on a particular worker node, so that inter-node communication is not required. So, and moreover, integrity can be better maintained. So the reality is we have to acknowledge that databases has a natural tendency to be monolith. It cannot be modular, which is against the concept of application design. Application want to be modular, but database will be monolith at the end of the day. And even if I retrospectively look at people hosting on Kubernetes environment, what I see is their database has grown to TBs, many hundreds of GBs or TBs. That is the current reality, because there is no way to detach it and move on. And another narrative which comes from the Kubernetes side is treat everything like a herd, so like a cattle. So we don't have to be specific about some database or something. But the reality is we need to be really specific. We need to be very closely monitoring the behavior of each database and session and its concurrency, all the problems. Even at the object level, we should be monitoring and its health, fragmentation, bloating. So database tuning, SQL tuning need to be done for a very specific SQL, not for the entire infrastructure. No, the problem is with a specific SQL, backup tuning, planning, all those things. So I had a personal case where for one particular system, the user was facing a problem of val archive slowness in val archiving. And then I suggested, okay, for this system, we need to have parallel valve push, parallelism in val archiving, and that should be asynchronous, so that we can address this problem. And they done it, and the problem went away. So the same team come back to me and said, okay, so let us implement it throughout the infrastructure for all the databases. That got me into surprise, because I recommended it for one specific case, but they are thinking about the entire infrastructure. That is not how the database need to be built. Say, for example, if a doctor recommends a remedy for a particular patient, that is for that patient, is not for the entire city or entire population. So we need to be very specific about that. So databases are always pet. So we need to, and we name it, say sales database, HR database. And each of them will have development database, testing database. So there is nothing in common. Even the behavior also changes. So we often gets the complaint that it is not working in production, but it is working in development, because the assumption is both are identical. So they even say that these are identical databases, but the reality is in databases there is nothing identical. There is no two databases identical. It's just like your fingerprint. It's two databases are different, and we need to be carefully nurturing each database. So the requirement is different for each database and the problems are different. So we cannot, there is no provision of handling the entire clusters as a just like a cattle. Yeah, so quickly, my suggestion is treat operator environment like a database as service, prepare DBAs facing documentation. So need to have documentation for DBAs and assign responsibility for DBAs. These are the things to be taken care. Otherwise, I see cases where there is no one in the seat and problem happens, and it becomes a very, very difficult situation to manage. The day-to operation management is unavoidable. There should be someone to take care, and basic DBA skills for support of operation environment. So the person who is in seat should have clear understanding of database concepts. Say if they are managing Postgres, the Postgres related terminologies and all those things. Otherwise, the communication become difficult. Say application or developers or external support may be communicating to them in terms of database language, explaining them the problem. Then the person in the seat should be able to understand those terminologies, what went wrong, what are to be improved, all those things. If the person don't know the database terminologies like how the Percona works and the backup tools like PG Backrest works, then the communication itself will become difficult, and we have cases where that resulted in problem. And jumping into the memory management quickly, memory requirements. This is the idea I took from Bruce Mountain. He had a wonderful presentation. So what basically he says is, this is how the typical application workload looks like. So there'll be a lot of CPU utilization, because application is all about computation, and there will be memory utilization and there will be a little bit of I/O. But the database requirements, requirements are different. There may not be much of CPU utilization, but we require a lot of memory. And database is all about I/O, because end of the day, database is all about storing and retrieving. This is I/O. So we require a lot of I/O, and to reduce that I/O, a lot of things to be cached in the memory. So we require a lot of memory. And please visit his presentation. This is the link where you can get his slides. So the important point to note is the query performance heavily depend on the availability of memory, and Postgres expects a lot of OS level cache, the OS page cache, and it is common. The RAM hundreds or thousands times faster than typical cloud storage. And when it comes to operator or the Kubernetes environment, we may see a documentation saying that a few GBs, 2 GB, 4 GB, all those things mentioned in the documentation. Please don't do that to your real production environment. That is not sufficient for a database workload. For database workload, we need to have a big memory. We need to have maybe much bigger memory based on your active data set. Please assess that and assign. So database requires lots of memory. Memory in container world. Each container is isolated in terms of isolated from rest in terms of memory. So container is an isolated box. So that requires memory to be assigned or allocated for that box. So the page cache is counted as part of container's usage. So generally in a regular hosting in a machine, the Linux page cache will be a kind of available memory or a freeable memory. That is the term we use. It's not considered as usage. But when it comes to operator, that piece of memory cannot be used by any other container. That is allocated for that specific container. So that is considered as part of that container's usage. So, and there is a beautiful discussion in this link. Please go through that, and there is a lot of things to learn if you are not familiar. And there won't be any cushion effect. So what is cushion effect is, say for example, if there is a spike in a database load, and or a sudden increase in memory utilization. So the new requirement will push the existing system little side and start consuming lot more memory or resources. So the other part of the system may become slightly slower, but the new requirement won't fail. Say some of the SQL requires lot more memory in terms of work mem. So that will have a small effect on the rest of the system, but it won't fail, because as an entire system it has a cushion effect. But when we partition the things into small boxes, we lose that cushion effect, because the things in the other box cannot utilize the resource in the any other boxes. Each container sidecar has its own limits, which acts as a strict boundary. So that's what I want to say. And there is a good news. Historically, Kubernetes requires the SOAP to be off, but from Kubernetes 1.28 plus supports SOAP of Linux nodes via node swap. So this is something new. I am also not utilized these things, but this is something new came in when I'm discussing the problems with the Kubernetes experts. So I am expecting this to solve a lot of these sudden spike handling cases. Instead of resulting in out of memory and port termination, this swap should help to absorb that sudden spike, at least without causing an outage. Reality is we need to account for page cache, process memory, and shared memory, all those things. So if we are not keeping the sufficient memory in each container, we should expect out of memory terminations. Yeah. And another point about memory is huge pages. For Postgres, huge pages are almost mandatory. There is, it's not optional. And I explained the details in this blog post, because the Linux memory accounting works in a specific way, which works against the Postgres memory accounting. Without huge pages, there is high chance of out of memory kicking in. So generally, if some out of memory case getting reported to me, the first thing which I look is whether the Postgres is using huge pages or not. And please visit the blog post for more details. It's mandatory. And the good news is the modern operators like Percona operator 2.8 onwards, we have provision to use huge pages. Please make use of that to avoid the disasters later. And please remember, huge pages must be enabled and pre-allocated on the Kubernetes nodes. So it won't automatically happen. If the huge pages are to be available on the node, then only Postgres can, the pod can utilize that. And we discussed about this container-wise memory slicing. This resulted in a lot of outage cases. So I thought of representing that boxes here. And this hierarchical memory is something which a C group does. That's a big topic to discuss. But please be aware that we need to allocate memory for each containers. And since each container has its own memory, the slicing, we need to specify the resources for each container. Say this is just example from Percona operator. So for example, the case which I told, the parallelism of backup. If the parallelism need to be increased, so we need to increase the resource allocation very carefully, very carefully for the PG backrest containers. Otherwise, that container will get affected. So everything which we do need to be very carefully adjusted for the corresponding containers. Otherwise, there is a chance of going out of memory, or some weird behavior could be happening, which is very difficult to troubleshoot. Say if the memory allocation fails internally somewhere, that may not be very evident in some cases. At least some of the tools won't clearly say that. So that is something. Okay. Then availability and performance quickly. This is another important point which I want to mention. Availability is kind of say, assume that there is a quick node failure without any delay. Then primary went down, immediately another primary took over. And theoretically, this is 100% available system, because there was no downtime in terms of database availability. However, we should remember that all database connections are stateful, session oriented, and end-to-end connections. And sessions cannot fail over or move from one machine to another. So that means every switchover, failover is a termination of the existing session. The existing session will be lost, and running transactions will be aborted and rolled back. And majority of the cases, application will have downtime. Many parts of the application may crash. So frequent failover, switchover, all those things are happening, please don't claim it's highly available. Theoretically, it could be highly available, but practically it affects the business. And the application need to be carefully designed to handle that situation of loss of session. Otherwise, application crashes. Yeah, so there will be downtime when a pod get terminated. This is different from application behavior, the stateless applications, right? That we may not see much of problem there, but databases, it is outage. And high availability is all about avoiding single point of failures. So there shouldn't be any single point of failure. So basically that means shared nothing shared architecture, that is generally called. And we should have underlying storage devices separate, network things separate. So if at all there is some shared stuff, that means there will be single point of failure, and some or other day we may have to face that. And performance, database is IO oriented, all these things we already mentioned, and database heavily depend on the network, and the TCP stack is horrible because that is designed in last century. It never improved. In last 20-30 years, we are measuring network latency in milliseconds. Still we are measuring in milliseconds. It's not much improvement there. And yeah. So when we have all the network stacks built up, IP, NAT, all those things, please be aware there will be performance degradation. And the day-to operations, we mentioned many of these things, and the list is not ending there. If we look at a typical database operation, there'll be continuous improvement, continuous delivery, continuous troubleshooting, fixing, improving. So there'll be continuous work involved from the DBA side, and security and compliances, capacity planning. So the list is actually big. I cannot accommodate everything. But what I want to mention is, please make sure that there is a knowledgeable person available. Otherwise, things are difficult to manage. And platform as layers. So when we have Kubernetes, we have one more layer getting added. So one more layer doesn't mean that we can ignore things in the underneath. If I recollect all the troubleshooting which I have done, end of the day, I had to involve people from the rest of the stack. Making sure that there is a proper communication, proper alignment, proper channelization exists for all the layers are already existing and proven, then only we can actually have a peaceful way of running Postgres on Kubernetes. And virtualization and containerization, this is something which we often discuss. The containerization comes as a replacement for virtualization, but reality is majority of the current containerization runs on the top of virtualization, which say many of the surveys shows that 80-90% of the containerization currently runs on the top of virtual machines. So what we today see majority of the cases is both virtualization and containerization. It's a stack built on the top of that. It is not a complement. It's not this or that. It is this and that. So we may face problems of both. So yeah. So if you are running Kubernetes on operator on Kubernetes, please have discussion with experts. So if you are running Percona operator, talk to experts in Percona, and what all operator you are running, be aligned with them, always be in touch with them to have proper guidance, because version after version behavior may change, new improvements may come. So the continuous communication is important. With that, I'm concluding my presentation. Thank you everyone for listening.